Uh, Good morning, everyone. Welcome to today's class, lesson number 6 of module number 3, in which we are dealing with the concept of leveling. Okay, let us start today's class. Okay, before that, okay, there are 3 methods of leveling. Okay, there are 4 methods of leveling: barometric leveling, hypsometric leveling, direct method, and indirect method. You will be learning about indirect method in your next semester, second part of the surveying. In this semester, you will be thoroughly learning about the direct method of leveling. In direct method of leveling, we are using a level instrument and we are using a leveling staff. And in direct method of leveling, there are different types of leveling. Different fly leveling, check leveling, and reciprocal leveling. So I was in the previous class, I was explaining about how the calculation or how the elevation of a point is calculated in direct method of leveling. Okay, I'll just repeat that. Okay, so first we have the datum. Okay, so this is the datum. Datum is the reference from which all the elevations are measured. Next, we have this ground profile. So I told you about one more term called as benchmark. Let's say this is my benchmark, and benchmark is a point whose elevation is known. Elevation is vertical distance from the datum. So vertical distance of the benchmark from the datum is known. So this vertical distance is already known. Let's say elevation or RL is equal to 500 meters. So this is my benchmark. Of RL 500 meter. So all the leveling surveys start by taking a staff reading on the benchmark. Now, let's say I have the instrument here. And I have leveled the instrument and all. Next, so this is the line of sight of the instrument. It is passing through the center of the telescope. Okay, next. So this is the line of sight. You have to remember all these terms: datum, benchmark, RL or elevation or line of sight. So next I'll keep the leveling staff on the benchmark. And I will, from the leveling instrument, I'll sight the staff and I will take the reading. So let's say we get a reading of 2.2 meters. So this staff reading, okay, which is taken on benchmark, which is taken on the point whose elevation is known to us. Now this staff reading is called as backside. So in we write it as BS. So backside is a staff reading taken on a point whose elevation is known. So any staff reading that is taken on benchmark, we already know what is the elevation of the benchmark. So any staff reading which is taken on the benchmark is called as backside. Next, I want to find the elevation of this point. Let's say this is the lowest point and I want to find its elevation. So before that, okay, after you take backside, you can measure the elevation of the line of sight. Okay, after you take backside on the benchmark, after you take backside on a point whose elevation is known, you can measure the elevation or the vertical distance of line of sight from the datum. Now this elevation or vertical distance of line of sight from the datum is called as HI or height of instrument. Height of instrument or plane of collimation. It is 500 plus 2.2. So it is 502.2 meters. So we can generalize this formula, or we can write it as HI is equal to RL of benchmark plus backside. Okay. Next, after calculating the height of the instrument, you can calculate elevation of any point. Let's say I want to calculate the elevation of point A. So this is point A. So I'll take my staff, take the leveling staff, and I'll hold the leveling staff on point A. And through my telescope, okay, along the line of sight, I'll take staff reading. Now let's say this staff reading is equal to 2.5 meters. Now, if this staff reading is equal to 2.5 meters, okay, and also I'll tell you one more term here. This staff reading, which is taken on point A, we do not know what is the elevation of point A. So staff reading, which is taken on point A, whose elevation is, it can be called as FS or IS. Okay, so this particular staff reading, it can be called as FS or IS, but that is intermediate sight or foresight. The difference between intermediate sight and foresight is that foresight is a staff reading taken on a point whose elevation is unknown, and it is the last reading of the survey. It is the last reading before shifting the instrument. So here, and intermediate sight is a staff reading taken on a point whose elevation is unknown, but it is not the last reading. After taking this staff reading, we will take further staff readings on different points. So after point A, let's say I want the point. So this is not my last staff reading, but taken on point whose elevation is unknown is intermediate sight. Okay, intermediate sight. In short, it is written as I. So now I want to find RL or elevation of point A, and I have taken intermediate sight on point A. So how do I measure the elevation of point A? Elevation of point A meaning vertical distance of point A from datum. So this is the elevation of point A. So this is RL or elevation of point A. Now, how do I find this vertical distance? I already know what is the height of instrument, that is elevation of line of sight. So I'll just mark it here. So this is the elevation of line of sight, which is equal to 502.2. So by simple subtraction, you can find the RL of A. So this length is 502.2. Now, how do you find the green length? Anyone? RL of A is equal to phi naught 2.2 minus 2.5. That is height of instrument minus intermediate site. So this answer is equal to 499.7. So you can generalize this formula. RL of any point is equal to height of instrument minus intermediate site. Next, let's say I want to find elevation of another point B. So this is point B. So if I want to find the elevation of point B, I'll have to hold the staff on point B. So I'll hold the staff on point B and I'll take staff reading from the level along the line of sight. Let's say the staff reading is equal to 0.4 meter. Now this staff reading of 0.4 okay, it is taken on point B and elevation of point B is unknown. We do not know, as of now, we do not know what is the elevation of point B. So this staff reading, and also this is the last reading I'll take. After this reading, I'll end my survey. So this particular staff reading of 0.4, which is taken on point, whose elevation is unknown, it is called as foresight. In short, it is written as FS. So please know the difference between intermediate site and foresight. Foresight and intermediate site, they are both readings taken on point whose elevation is unknown, but foresight is the last reading, and intermediate site, as the name itself says, it is intermediate reading. It is not last reading. So foresight is 0.4. So I want to measure the elevation of point B. So I am taking foresight on point B. Elevation of B or RL of B is nothing but the vertical distance of B from datum. So this is a vertical distance of B from datum, the blue line, and it is RL of B. RL of B is equal to, okay, again I will need the height of instrument or the elevation of line of sight. So this is the elevation of line of sight. So from this elevation, if I deduct this staff reading, I can calculate RL or elevation of point B. So height of instrument minus foresight. So I can generalize this formula. And height of instrument is constant, phi naught 2.2 minus foresight is 0.4. And answer is phi naught 1.8 meters. So this is how you calculate elevation of different points with respect to datum. And for all the important large scale surveys, usually datum is taken at mean sea level. Let us not worry about that, but for small surveys, you can assume any arbitrary datum or arbitrary benchmark. So I hope you have understood this concept. If you have understood this, just raise your hand so that we can go to next concepts. This is the most basic and the most important concept. If you don't understand this, you won't understand the calculation part of the leveling. Okay, moving on. Okay, the first type of leveling is differential leveling. Okay, in direct method of leveling, there are many types of leveling: differential leveling, fly leveling, profile leveling, check leveling, reciprocal leveling, etc. So first, we also have simple leveling. So I'll first explain simple leveling. Okay, in simple leveling, we are finding the difference in elevation between 2 points. Okay, so if this is my ground level and this is the datum, let's say I want to find the difference in elevation between 2 points, and the first point is here. Let's say it is a benchmark. Okay, so it's a benchmark. Point A is a benchmark. And the elevation of this benchmark is let's say 750 meters from datum. I want to find elevation of a point. Say the point is here, point A. I'll set up the instrument somewhere in between these 2 points. So from the instrument point, this benchmark is also visible and point A is also visible. So I'll level the instrument. Let's say this is the line of sight. Okay, so I know. So this is a benchmark. It means I know what is its vertical distance or what is its RL. It is 750 meters from the datum. So this distance is 750 meters from datum. Okay, so always I told you leveling survey starts from taking a staff reading on benchmark. So I'll take a staff reading on benchmark. I'll hold the staff here. And let's say along the line of sight. So this is my line of sight. Along the line of sight, I get a staff reading of, let's say, 3 meters. So I get a staff reading of 3 meters. Now, I told you staff reading taken on a point whose elevation is unknown is called as backsight. Now this staff reading is backsight. Now, when I take backsight on a benchmark, I can easily measure what is the elevation of line of sight. So this is the elevation of line of sight. That is vertical distance of the line of sight from the datum. So this is called as HI, height of instrument. So height of instrument is given by RL of benchmark plus backsight. So RL of benchmark is 750 and backsight is 3 meters. So height of instrument is 780 meters. So after taking staff reading on benchmark, I'll hold the staff on point whose elevation I want to find out. So I'll hold the staff on point A.
Sir, 753, sir.
Okay, sorry. Sorry, 750 plus 3, 753. Okay, next I'll hold the staff on point A and I'll take one more staff reading. Let's say this staff reading is equal to 0.5. Now this staff reading is 0.5. Now this particular staff reading taken on point A, we don't know what is the elevation of point A. So this staff reading, and also we know that it is the last staff reading. I want to find the elevation of point A. So I'll take the staff reading on point A and I'll end my survey. So this staff reading taken on a point whose elevation is unknown and it is the last reading. Now this particular reading is called as foresight. Okay. So I'll take foresight on point A. I want to measure the vertical distance of point A from the datum, that is elevation of point A from the datum. And this vertical distance is given by, so I have height of instrument. So this is height of instrument. So height of instrument minus the staff reading at A. It will give me elevation of point A. So height of instrument minus foresight will give me RL at point A. So elevation or RL of point A is equal to height of instrument minus foresight. So height of instrument is 753 and foresight is 0.5. So answer is 752.5. So simple leveling, the points are nearby. Okay, so we'll set the instrument in the center of these points, in between these points, and we'll take the staff readings on these 2 points and we'll find the RL of the points, RL of a point, or you can also find the difference in elevation between these 2 points. So benchmark is at an elevation of 750 meters. Point A is at an elevation of 752.5 meters. So the difference in elevation is 2.5 meter. So this is simple leveling. You are trying to find elevation of 1 point, or you are trying to find the difference in elevation between 2 points. So this is simple leveling. Next is differential leveling. You will be doing this a lot in your lab or when you're in highway projects, railway projects, or canals, etc. You're doing this. Okay. When you want to find, let's say, difference in elevation or RL of a point, but let's say okay, take our campus for example. So we have civil department here. Okay. So this is the civil department. There is ground behind. So here we have a path. Here we have a first year block. So here we have main building, library and main building. So let's say this is the porch where all the vehicles are parked. College vehicles are parked. So let's say, and here we have the porch of civil department. Okay. Let's say I want to find the difference in elevation between this point, point A, and this point, point B. So if in simple leveling, both points were nearby. So if point A is here, point B was somewhere here, and I set up my instrument in between those 2 points, and I found out the elevation. But here, both the points are far from each. So you have to change the instrument many times to find the difference in elevation between those 2 points. If the 2 points are nearby, okay, I'll set up my instrument only once and I'll take staff reading on those 2 points from the same point, because those 2 points are visible from that particular instrument station. Okay, if I want to measure, this is point A, this is point B, and they're both nearer to each other, I'll set my instrument in between such that both the points are visible. Here, that is not the case. You cannot select a point and set the instrument such that the point A and point B are visible from that particular point. So here we are doing differential leveling. That is, we are changing the instrument many times. So here we have to take change points. So I'll just explain the concept. Okay, so this is point A. Here we have let's say I'll take this as arbitrary benchmark. I'll assume I don't have any benchmark nearby. Okay, the nearest benchmark is at Alnavar railway station, and to measure the difference in elevation between point A and point B, which is in our college campus. Okay, I don't want to go to Alnavar. I don't want to start the survey from Alnavar, which is 12 kilometers away from our college. So what I'll do, I'll assume a benchmark. Okay, so I'll assume a benchmark and I'll assume its elevation as 100 meter from the datum. So here I'm not assuming mean sea level as datum. Actually, the average elevation of Halyal is 750 meters from the mean sea level. But for my survey, which is of very small scale, I'm assuming benchmark as 100 meter from the datum. So I'm assuming an arbitrary datum and benchmark. Okay, so first I'll set up the instrument here. Okay, and I always told you leveling survey starts from taking a reading on benchmark. So I'll hold the staff on benchmark and I'll take reading on benchmark. Okay, what is this staff reading called as? Elevation of benchmark is already known. So staff reading taken on benchmark is called as, these are all very important when you are tabulating. Okay, so it is called as backside. Next, I want to measure elevation of point A. So I have to take staff reading on point A. So I'll keep a staff on point A and I'll take staff reading from my leveling instrument. So do I know what is the elevation of point A? So staff reading taken on a point whose elevation is unknown. It can be a foresight or it is intermediate site. Now, this particular reading is intermediate site. Intermediate site. Now next, can I, is point B visible from this instrument? No, it is not visible. So I have to change the instrument. I have to go towards point B. So what I'll do, I'll select a change point. Okay, I'll select a suitable change point. Let's say I will select the change point here. Okay, I'm selecting the change point here, and I will take reading on change point. Okay, so this particular point is called as change point, and in short, it is written as CP. It is even called as turning point, so or TP. So change point or turning point. So I'll take staff reading on change point. I'll select a suitable change point and I will take staff reading on the change point. Now, after taking staff reading on the change point, I'm going to shift my instrument here. I'll move it nearer to B. So after taking staff reading on change point, I'll be shifting the instrument. So this is the final reading, final staff reading from this particular leveling station, from this particular instrument point. So this staff reading taken on a change point whose elevation is unknown. I don't know what is the elevation of change point. And after taking this reading, I'll be moving my instrument or shifting the instrument to another point. So this staff reading is called as foresight. I told you foresight is a staff reading taken on a point whose elevation is unknown, and it is the last staff reading of the survey or before shifting the instrument. So it is the last staff reading from this particular instrument point. So it is called as foresight. Now after this particular reading, I'll shift the, so I'll shift it here. I'll nearer and nearer to B. So I'll keep the instrument here. Now, once I take staff reading on any point, I can calculate its elevation. I showed you when I was explaining direct method. If I hold a staff on a point, I can easily calculate its RL or elevation. That is, RL of any point is equal to height of minus foresight or backside. So at this point, okay, benchmark elevation of benchmark was known before we started the survey. After I took staff reading on A, I calculated the RL of A or elevation of A. After I took foresight on change point, I calculated the elevation of change point. Now, after taking staff reading on change point, now I have shifted my instrument. This change point, it acts as benchmark because after taking the foresight on change point from this particular instrument, okay, instrument point, let's say 1, I have calculated the RL of change point. Now, when the instrument is at instrument station 2, I know what is the elevation of change point. So this particular point, change point, it acts as benchmark after the instrument is shifted. So I'll take a staff reading on change point whose elevation is now known to us. So this particular staff reading is called as backside because I know what is the elevation of this change point. Next, let's say I want to collect or calculate RL of some other points. Let's say I want to calculate, here we have store, okay, the cooperative society store. I want to calculate the RL of the particular store or elevation of that store. Let's say this is point C. So I'll take a staff reading there also. So I'll take staff reading on the store. Okay, and this particular staff reading, okay, I don't know what is the elevation of point C, and it is also not the last staff reading. Okay, so that particular staff reading, it is an intermediate site. Now I have to choose a change point. Let's say I'll choose my change point here, so that I'll shift the instrument and I can take the staff reading at B. So this is my second change point. I'm taking the change point near the library. Change point 2. This was change point 1 or turning point 1. Okay. I'll take staff reading on change point. Now this particular staff reading on change point, it is foresight, because I don't know what is the elevation of change point. Okay. And it is the last staff reading. After taking this staff reading, I'll be shifting the instrument. So after taking the foresight, I'll shift the instrument. So I'll shift the instrument here. Now, when I take foresight, I can calculate the elevation of change point. So after shifting the instrument, I know what is the elevation of change point. So I will take staff reading on change point, and this particular staff reading will be backside, because after taking the staff reading from instrument point 2 on change point, I can calculate the elevation of change point. And now after I have shifted the instrument, I already know what is the elevation of this change point. So this particular staff reading is backside. And finally, from this particular instrument point, that is from instrument point 3, point B is visible. So I'll take staff reading on point B, and that is going to be my last staff reading. And hence this particular staff reading is called as foresight, because it is the last staff reading. After this staff reading, I'll end the survey. So this is foresight. So this is an example of differential leveling, where the 2 points between which I want to find the elevation are far from each other and they are not intervisible. Okay, you cannot set instrument in between those points, and at one go you cannot points from a single point. Okay, so I hope you have understood what is simple leveling and what is differential leveling. If you have understood what is differential leveling, please raise your hand. You will understand this much better. What is foresight, backside, and okay, all these readings are tabulated. And how these readings are tabulated, I'll explain it with example in the next class. So I hope you have understood the concept. Okay. I'm going very slow because this is the most important module or concept. Okay, I'll explain this, the same thing in the next class, but with values and how these values are tabulated or how the observations are taken. So the next class is on Thursday. So we'll meet on Thursday. Thank you for attending the class, and if you have any doubts, you can ask. If you don't have any doubts, you can leave.